In this video tutorial, we're going to analyze questions from part 1 of the Geometry 2018 Regents, and we'll start with question number 1 that says, in this diagram below, AEFB and CGD are parallel to one another. So I'm going to indicate that like so. And it also says that segment GE and GF are drawn. Tremendous. So it says if EFG, which is this angle right here, is 32 degrees, and AEG, which is this angle, is 137, what is EGF? What is angle EGF? We're going to have to figure out the measure of that angle, and let's go through this right now. So it says if EFG is 32, I'm going to mark that like so, and if AEG is 137, I'm going to indicate that right here. Once again, our objective is to figure out what this angle is, and I recall that the sum of the three interior angles of a triangle equals 180, so let's figure out what this angle is. I recognize that this angle and this angle form a linear pair relationship. So 180 minus 137 gives us, of course, 43. And I know that 180 minus 43 minus 32 is going to give us EGF. And so 180 minus 43 minus 32, of course, is 105. And is that an option? It sure is. The correct answer to number 1 is option 4. If triangle ABC is mapped onto DEF after a line reflection, so what might that look like in this quick sketch? After a line reflection in triangle DEF is mapped onto XYZ after a translation. Okay, we've got XYZ right here. The relationship between ABC and XYZ is that they are always what? Well, I recall a few things. If we're talking about reflections and we're talking about translations, distance and angle measure are always preserved. And so that means that the only option is that they are congruent and similar. The correct answer to number 2 is option number 1. Question number 3 says, an isosceles right triangle's legs measure 6 is continuously rotated about one of its legs to form a 3D object. Let's sketch out what that might look like right now. So if we're going to have an isosceles triangle, I recognize that it's going to look a little something like this because it's isosceles. The legs are congruent, and they are, in this case, each 6. What else do we know? We say that it's continuously rotated about one of its legs, so it could be rotated around either this leg or this leg. I guess we'll just do this one for the purposes of this tutorial. And so this leg is going to be spinning around. Okay, great. And what shape will this form? Well, the 3D shape, of course, it's going to form is a cone. That's pretty obvious, right? But what about the diameter? Well, if we extend it from here to here, we know that 6 is the radius. When we double it, the new diameter is 12. So the correct answer is option 4, a cone with a diameter of 12. Let's take a look at question 4. It says, in this regular hexagon shown below, all these segments intersect at G. And at the bottom it says, when triangle ABG, which is this triangle right here, is reflected over segment BG, okay, so if it's being reflected over this segment right here, and then rotated 180 degrees about point G, where is ABG, this original triangle, mapped? All right, so if we're starting right here, it's reflected over BG, it's now, ABG is now BCG, so the new triangle is this right here after that reflection. And then if it's rotated 180 degrees, we know that it's simply spun to right here. So the new transformation carries it to FEG. Is that an option? It sure is. The answer to question 4 is option number 1. Question 5 says, a right cylinder is cut perpendicular to its base. It's making a 90-degree angle. And it says the shape of the cross-section is which of these 4 objects? To help me visualize this, I'm going to make a quick sketch. I would encourage you guys to do so as well. It certainly doesn't have to be perfect. And what do I know? I know that if it's forming a perpendicular angle from the base, it's going to look a little something like this. And what shape is this cross-section? Is it a circle? No. Is it a cylinder? No. Is it a rectangle? It is. We know it's not a triangular prism. So the correct answer for number 5 is option 3, a rectangle. Question 6 says, Yolanda is making a springboard to use for gymnastics. She has 8-inch tall springs and wants to form a 16.5-degree angle with the base, as modeled in the diagram below. To the nearest tenth of an inch, so we're going to be rounding, what will the length of the springboard be at x? What is the length of this side of this right triangle right here? Well, we're going to need to recognize that we're using our trig ratios, and is it sine, cosine, or tangent? Well, I know that if we're looking at it from the 16.5-degree perspective, we're going to be using opposite over hypotenuse. And so, as a quick reminder, sine is so kato, right? So it's opposite over hypotenuse. And in this case, it's going to be sine 16.5 equals opposite 8 inches over x. That's the unknown length of this springboard. So when we isolate for x, so x equals what? It's going to be 8 over sine 16.5. And when you plug that into your calculator, what do you get? We're going to get x equals 28.16742. We're rounding to the nearest tenth of an inch, so that's going to be 28.2. Is that an option? It sure is. The correct answer is option 4 for question number 6. Question 7 says, in the diagram below of right triangle ABC, altitude BD is drawn to hypotenuse AC. So let's mark this up right now to indicate that this is a right triangle. So we got the 90-degree mark. This is also 90 degrees. Altitudes, of course, are perpendicular to the hypotenuse, which we have right here. And it says if BD is 4 and AD is x minus 6 and CD is x, what is the length of CD? So our objective in this problem is to figure out what the length is of CD. Well, how are we going to do this? We know that when we have right triangles with altitudes, we can use geometric means to find the missing sides of these triangles. So I'm going to sketch out this right here. And what do we know? We know that if this is the height, and this is x, and this side is y, we can use the formula the h squared equals x times y. So now let's plug in these values. If BD is 4, and AD is x minus 6, and CD is x, what can we do? We know that it's going to be 4 squared equals what times what? It's going to be, let me check our formula over here, x times y, so it's going to be x times x minus 6. Great. And so, of course, now we're going to need to distribute. And so we've got 16 equals x squared minus 6x. And when we set this equal to 0 and we subtract 16, of course, from both sides, we've got x squared minus 6x minus 16. So now we need a factor, and we can simply set it up like this. And when we factor, we need to think about what two numbers multiply to negative 16 and add to negative 6. Well, I know, of course, x times x is going to give us x squared. And I also recognize that negative 8 and positive 2 will give us, when foiled, x squared minus 6x minus 16, right? And so now because these are set equal to 0, we've got x minus 8 equals 0, and we've got x plus 2 equals 0. So x equals 8 or x equals negative 2. We know that we can't have a negative number for a length. That doesn't make sense, right? So the only viable option is x equals 8. Is this an option? We've got 5, 2. Option 3, 8. Option 3 is the correct answer. 8 is the length of CD. Question 8 says, rhombus star has vertices S, T, A, and R. What is the perimeter of rhombus star? Well, the first thing that I'm going to do is ballpark a quick sketch of what this might look like. And I know that S is -1, 2, so maybe right there. T is 2, 3, so approximately right there. A is 3, 0, and then R is O, -1, so maybe right there. We're going to pretend this is a beautiful rhombus. Okay. It says, what is the perimeter of rhombus star? So what we're going to need to do is figure out the distance from any one of these sides and then simply multiply it by 4. To do that, we're going to be applying the distance formula. And we remember that the distance formula is radical x2 minus x1 squared plus y2 minus y1 squared. Okay, great. So now what we need to do is pop in these values. I'm going to do, I feel like T and A are going to be the easiest numbers to work with. So what I'm going to do is simply label XY, XY. That way I don't get confused. And let's pop these in. All right, I'm going to set this up. Great. So we'll pop in the X values first. So I'm going to do 2 minus 3. And then we've got the Y values. We've got 3 and 0. So I'm going to do 3 minus 0. And what do we know? We know that 2 minus 3 is going to give us -1. And we know that 3 minus 0 is simply 3. -1 squared is going to be 1. 3 squared is going to be 9. So we know that 1 plus 9 obviously is 10. So the distance from the distance of each of these sides is radical 10. But if we're looking for, of course, the perimeter, we're going to need to multiply radical 10 by 4. And so the perimeter is 4 radical 10. And is that an option? It is option number 4. 4 radical 10. Here we have two triangles, and I notice that angle H and angle N are right angles, and I can see that this triangle is similar to this triangle. Tremendous. I also notice that it says if side AR is 13 and HR is 12, what is the measure of angle Y to the nearest degree? So we're going to be rounding. The first thing that I'm going to do is indicate which angles are corresponding. So I see that, of course, angle H corresponds with angle N. I see that angle A, of course, corresponds with angle T. And then critically, angle R corresponds with angle Y. And that's going to be really important in a moment. I can see that AR is 13. And I can see that HR is 12. All right, so how are we going to figure out what angle Y is? Well, I know if they're similar, the angle measure of R is congruent to the angle measure of Y. So we need to figure out what the angle measure of R is. To do that, we're going to use our trig ratios. And I know that we've got the adjacent side right here. And I also know that we have our hypotenuse. So what trig ratio includes both the adjacent and the hypotenuse? It, of course, is cosine. So I know that cosine equals adjacent over hypotenuse. And let's simply plug that in. But here's the issue. We don't know what the angle of R is, right? So we're trying to figure out what angle R is. So we're going to use the inverse function. So let's do that right now. So angle R equals the inverse of cosine times the adjacent over the hypotenuse. And I can see that it's going to be the adjacent is 12. The hypotenuse is 13. And when we plug that into our calculator, it's going to give us 22.621986. And if we're simply rounding it to the nearest degree, R is going to be what? 23 degrees. Is that an option? It is. But again, because we're looking for the measure of angle Y, we know that R and Y are congruent. Y is also 23 degrees. And therefore, the correct answer is option 1 for question number 9. Let's take a look at question number 10, and it says that in this diagram below, critically segment AN and segment SC are congruent with one another. So I'm going to include that right there. And our objective is to determine which additional statement is sufficient to prove that triangle KAN, this triangle right here, is congruent to KSC by AAS, by angle, angle, side. And I'm going to write that up here for point of emphasis. So we need to establish an angle, angle, side congruency. We've got already the side done. And before I look at the four options, I'm wondering if there's anything else we can do to indicate that there is an additional angle in here that we can find right off the bat. And I notice that when I'm looking at this intersection, we've got vertical angles. And so I'm simply going to mark that like so. And there we've got our vertical angles. So we need to simply find one more angle. Let's take a look at our four options and see if any of these statements are sufficient enough to prove AAS. So it says that segment AS and NC bisect each other. So if AS and NC bisect each other, is that going to give us an additional angle? No. It would give us SSA, but that is not what we're looking for. So that's not what we want. I notice that option number 2 says K is the midpoint of NC. Would that statement give us angle, angle, side? An additional angle? No, that would simply give us another angle. Another side. And then option 3, it says if segment AS is perpendicular to CN, would that give us another angle? No, because we already established that these two angles are congruent because of vertical angles. So if these were 90-degree angles, that wouldn't change anything or give us an additional angle. But when we check option 4, it says segment AN and SC are parallel to one another. So I'm going to write that, I'm going to mark that up on our diagram. And I can see that if these are parallel, we've got parallel lines, and if they're cut by a transversal like we have right here, I recall vividly that alternate interior angles are congruent. So if we've got an alternate interior angle here and here, then that means that this angle and this angle are congruent. This is enough to prove that this triangle is congruent, that triangle KAN is congruent to KSC by AAS. Tremendous. Question number 11. Which equation represents a line that is perpendicular to the line represented by y equals negative 2/3 x plus 1? Well, the most significant element of this equation is the slope, and I know that the slope, of course, is 2/3, and we're looking for the slope perpendicular to 2/3, and that's going to be the opposite reciprocal. So it, of course, is going to be negative 3/2, right? We flip the numerator and the denominator. This is the slope that we're looking for, that ideally is in one of these equations from options 1 through 4. And when I'm looking at option 3, I can see that the slope is 3/2. Well, that's no good. We don't want that one, so we can eliminate that. I also notice that when we look at option number 4, I can see that the slope is negative 2/3. That's not negative 3/2, so we can eliminate both 3 and 4. Let's scrutinize option number 1 and 2. And we'll start with number 1. I can see that it's not written in slope-intercept form, so we're going to want to do that right now. And I'm going to rewrite it like 3x plus 2y equals 12. We know that we're going to want to subtract 3x from both sides. And when we do, we've got 2y equals negative 3x plus 12. And next, we'll divide both sides by 2. Great. And what are we left with? Y is isolated, and the new equation is y equals negative 3/2 x plus 6. And what do we notice? We notice that negative 3/2 is the slope. And you know what? That matches the slope that we're looking for. This is perpendicular to this original slope, indicating that option 1 is the answer. Let's take a look at question number 12. It says, in the diagram of triangle ABC, points D and E are on sides AB and CB respectively, such that DE is parallel to AC. All right, that's probably going to become pretty important. We'll talk about that in a moment. I also noticed that it says if EB is 3 more than DB. So if this length right here is 3 more than this length, we're going to have to mark that up in a moment. It says that AB is equal to 14 and CB is equal to 21. What is the length of segment AD? So I'm going to highlight that right now because we're definitely going to want to return to this. So this is our objective. All right, how are we going to figure this out? Well, I know that if we establish that this big triangle is similar to this small triangle, what we can do is set up a proportion that will help us figure out what this segment is. But before we do anything else, let's go ahead and label this. So I noticed that AB is 14. So I'm going to indicate that right here. This big side is 14. I noticed that this side right here, CB is 21. Okay. What else do I see? I see that EB is 3 more than DB. We don't know how much DB is, so we're simply going to call that X. And if EB is 3 more than it, we can simply say it's X plus 3. Great. So now we got to think about, can we set these triangles, as being similar to one another? We sure can. Because these are parallel, I know that we can say that this angle and this angle are congruent because they are corresponding. Likewise, for this angle and this angle, they're corresponding. And then, this angle is shared between both the small and the big triangle. This angle is reflexive. So they are certainly similar. Great. So let's set up this proportion. I know that we're going to have to think about how we're going to do that. So what over what equals what over what? So what I'm going to do is the small, let's set it up like this. It's going to be DB over BE, or EB rather, equals what over what. So I can see that this is the long leg over the hypotenuse of the small triangle. Is going to be the long leg over the hypotenuse of the big triangle. So it's going to be AB over CB. Great. So now let's plug in the measures. I know that DB, of course, is going to be X over X plus 3. And I know that AB is 14. And CB is 21. And so now what we're going to do is we're going to have to cross multiply. So 21 times X is going to be 21X. 14 times X plus 3. And we're going to have to simply distribute a little bit. So 21X equals 14X. And then 14 times 3 is 42. Okay. Let's combine like terms, and to do that, we're going to subtract 14x from one side and the other. And so 7x equals 42. That makes sense so far. And then we're going to divide both sides by 7. So x equals 6. Amazing. But I recall that the objective of this problem was not to solve for x. Instead, it says, what is the length of segment AD right here? So if the entire length is 14, and we know that x is 6, what is that going to make AD? Well, 14 minus 6 is going to give us 8. All right, so the answer is 8, and 8 is actually option, not 1, 3, or 4, but 8 is option 2. Amazing. Question 13 says, quadrilateral METH has both pairs of opposite sides congruent and parallel. Which statement about quadrilateral METH is always true? Before we scrutinize these options further, I'm going to do a quick sketch. And it's quadrilateral. Obviously, there's 4 sides. And let's label this like so. We've got MA, T, and H. Tremendous. All right, we know that opposite sides are congruent. We know that opposite sides are parallel. All right. Which statement is about this quadrilateral will always be true? So it says that MT, which is this diagonal right here, is congruent to AH. No, that's not always true. It's true if it was a square, right? So if this was a square, it would be true. But it's not always true. So we're going to eliminate option number 1. Option number 2, it says MT, which is this same diagonal is perpendicular to AH. No, that's not true either. If it was a rhombus, that would be true, right? So if it looked a little, maybe something like this, they would be, let's pretend that's a 90-degree angle, that would be true, but it's not always true. Let's take a look at option number 3, and it says that MHT and ATH, this angle and this angle, are congruent. No, like if we're just eyeballing it, we can see right now, no, that's not true. These are adjacent angles, no. But when we look at option number 4, it says angle MAT is congruent. MAT is congruent to MHT. You know what, ladies and gentlemen, these are opposite angles, and opposite angles are always congruent. So the correct answer is option 4. And question number 14, it says, in the figure shown below, quadrilateral TAEO is circumscribed around circle D. And it says the midpoint of TA, this segment right here, is R. So if this is the, if R is the midpoint, that would make each side congruent with one another. So I'm going to indicate that like so. And I also see that it says that HO is congruent to PE. So I'm going to indicate that right there. HO is congruent to PE. Amazing. You know what else I noticed, ladies and gentlemen? We've got some tangents, and I know that tangents from the same external point are congruent. So that means that TH is congruent to TR. I'm going to indicate that right here. That means that AP is congruent to AR. That means that ZE is congruent to PE, and that means that OZ is congruent to OH. All right, and so let's take a look at these further instructions. It says that if AP equals 10, and let's write that right there. AP is 10, okay, and EO is 12. What is the perimeter of this quadrilateral? Well, if EO is 12, I know that then this is 6, and I know that this is 6, right? I also know that this would be 6. Likewise, this would be 6. I know that because AR is congruent to AP, this is 10. As discussed, this is 10, this is 10. And then if we're simply identifying what the perimeter is, we're going to add up these values. So 10 times 4 is 40. 6 times 4 is 24. 40 plus 24 is going to give us 64. All right, so the answer to question number 14 is option 2, 64. Question number 15, it says the coordinates of the endpoints of the directed line segment ABC are A, negative 8, 7, C, 7, negative 13. And if AB to BC is a 3:2 ratio, what are the coordinates of B? That's what we're going to need to figure out right now. I'm going to sort of sketch this out. I know that we've got A here. I know that we've got C here because those are the endpoints. And I recognize that because it's a 3:2 ratio, we're going to have a total of 5 parts. All right. B is where it breaks it into a 3:2 ratio. So B is going to be right here, right? Because we've got 1, 2, 3 parts, and then 1, 2. And this is the coordinates that we're looking for. How do we figure that out? Well, the first thing that I'm going to do is write down the x values for A and C. So I know that A is negative 8, C is 7. I know that the y values are positive 7 and negative 13. And you know what I can tell? When I'm looking at the x values, it's going from negative 8 to 7, so they're increasing. And when it goes from, the y values are going from 7 to negative 13, so they're decreasing. We're going to figure out how much they're increasing and decreasing by for each unit. And to do that, let's think about just the x values. So we're going to want to find the distance from A to C, just the x values. And to do that, we're going to do the biggest minus subtracted by the smallest. And so 7 plus 8 is going to give us 15. So it's increasing by 15 units. I also know that we've got, for the y values, negative 13 minus 7. And that's going to give us, of course, negative 20. But the question is, how much is it increasing or decreasing by each unit? Well, we've got 5 parts. So what we're going to do is we're going to divide the x values by 5. And so I notice that it's increasing by 3 each time. And I know that when we divide negative 20 by 5, it's going to give us negative 4. So the y values are decreasing by 4 each time. All right, amazing. So now we're going to get the coordinates for each unit until we get to b. And I know that we're obviously starting off with negative 8. So negative 8 plus 3 is going to give us negative 5. So we're just going to do, again, the x values first. Negative 5 plus 3 is going to give us negative 2. Negative 2 plus 3 is going to give us positive 1. All right. Now we're going to be looking at the y values. We're starting with 7, right? And I know that it's 7 minus 4, and it's going to give us 3. 3 minus 4 is going to give us negative 1. And then 1 minus 4 is going to give us negative 5. All right, so now when we look at the coordinates, we figured out what the coordinate is for b. It's 1 comma negative 5. Is that an option? It sure is. It's option number 1. Question 16. In triangle ABC, points D and E are on sides AB and BC respectively, such that DE is parallel to AC. So I'm going to indicate that right now. And it says that AD to DB has a 3:5 ratio. All right, AD to DB has a 3:5 ratio. I also notice that it says if DB is 6.3 and AC is 9.4, what is the length of DE to the nearest tenth? So we're going to be rounding, and our objective is to figure out what the length is of DE, and we know, of course, what DB is, right? So DB is 6.3, AC is 9.4. How can we figure this out? Well, we said a moment ago that this segment is parallel to this one, so what we're going to want to do is establish similarity between the small triangle and the big triangle, and we can do that because if these are parallel, then we know that there is an angle relationship right here. These ones are corresponding. Likewise, this angle and this angle are corresponding, so they're congruent. So we just established AA similarity between the small triangle and the big triangle. Why is that important? Well, we know once we know that, we can say that the ratio of the small triangle to the big triangle is what to what? Well, if this is 5, what is the length of this side of the big triangle? It's not 3, it's 5 plus 3, which is 8. Oh, okay, so this has a 5:8 ratio from the small triangle to the big triangle. And so what does that mean? It means that DE and AC are proportional to this very same ratio. So let's set up this proportion. So I know that DE to what? To AC equals what to what? 5:8, just like we just said a second ago. And so now let's plug in some values. We know that we don't know what DE is, but we know that AC is 9.4. And so what we're going to need to do now is we're going to need to, of course, cross multiply. So DE times 8 is DE 8. And when we multiply 5 times 9.4, we're going to get this. We're going to need to next isolate DE. And to do that, we're going to simply divide both sides by 8. And so what does DE equal? What is the length of this segment? It, of course, is 5.875. And when we, what is this? To the nearest tenth. So when we round up, it's going to be 5.9. So DE equals 5.9. Is that an option? Sure is. Option number 3. Question number 17. In the diagram below, rectangle ABCD has vertices whose coordinates are 7, 1, 9, 3, 3, 9, and 1, 7. And it says, which transformation will not carry the rectangle onto itself? All right. What I'm going to do right now before I do anything else is I'm going to highlight the word not, because it looks like 3 out of these 4 options will carry the rectangle onto itself, but one of them will not. And we'll start with number 1. And I can see it says a reflection over line y equals x. So what is y equals x? That's when like y is 1, x is 1, y is 2, x is 2, and it's going to take this shape like so. And when it reflects, you know what? It's going to take the same exact shape. It's going to reflect over this line. It's going to look the same. So we know that we can rule out number 1. Option number 2, it says a reflection over the line y equals negative x plus 10. I can see that 10 is the y-intercept, and it's got a slope of negative 1. So what exactly is that going to look like? Here, of course, is the y-intercept, and if it's a slope of negative 1, the line is going to look a little something like this. And if it's reflecting over this line, again, it will carry itself onto itself. So we're going to rule out option number 2. Let's take a look at 3 and 4. So I know that with both 3 and 4, they are rotations of 180 degrees, but around different points. So option 3 is 6, 6, and 4 is 5, 5. So let's figure out where 6, 6 is. So I'm going to start right here at the origin. 1, 2, 3, 4, 5, 6. And I'm going to count up. 1, 2, 3, 4, 5, 6. All right, so I noticed that 6, 6, 6 is right here. And then I noticed that for option 4, interestingly, it's going to be 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. All right, so we've also got 5, 5 right here, right? So which one, if we spin it 180 degrees, will it carry onto itself? Obviously, option 4, it will carry onto itself at 0.55. But you know what? A rotation of 100 degrees, 180, around 6, 6 will not. So the correct answer is number 3. Question number 18 says, a circle with a diameter of 10 centimeters and an essential angle of 30 degrees is drawn below. What is the area to the nearest tenth of a square centimeter of the sector formed by the 30-degree angle? So our objective is to figure out the area of this slice right here. And to do that, what we're going to need to use is the formula for the area of a sector. And we remember that it is the number of degrees over 360 multiplied by pi r squared. So let's plug in these values. We know that the number of degrees is 30 over 360 times pi r. What is r? The diameter is 10, so the r, of course, is 5 squared. And now we can simplify just a tad. And when we do that, I know that the zeros cancel out. 3 divided by 36, of course, is 1/12 times 25 pi, right? And so now we've got 25 pi over 12. When we pop that into our handy dandy calculator, we're going to get 6.54498, and we're rounding it to the nearest tenth of a square centimeter. And the correct answer then, of course, is choice 2, 6.5. Question number 19 says, a child's tent can be modeled as a pyramid with a square base whose sides measure 60 inches and whose height measures 84 inches. What is the volume of the tent to the nearest cubic foot? So the first thing I'm noticing is that it's providing us with 60 inches of the base, 84 inches in the height, and yet it's asking us to provide the volume in cubic feet. All right, so we're going to need to be converting inches to feet. And I remember that 60 inches equals 5 feet. And I know that 84 inches equals 7 feet. Right? You can take 60 divided by 12, 84 divided by 12. Amazing. And I also recall that the volume of a pyramid is 1/3 base times height. All right. So let's plug in these values. We now have, of course, our information in the unit that we're going to be using for our final answer. And so the volume equals 1/3, and I know that the base is the length times the width, so it's going to be 5 times 5. And then the height, of course, is 7, right? We saw that right there. And when we plug this into our handy-dandy calculator, the answer is 58.3. And when we round it to the nearest cubic foot, it's going to be 58 cubic feet. That is an option. Option number 2. And question number 20 says, in the accompanying diagram of a right triangle ABC, I'm going to include that right here, showing that this is 90 degrees. Altitude BD, I see BD, and if it's an altitude, then this is also 90 degrees, is drawn to hypotenuse AC. All right, so we've got an altitude and a right triangle, and what that means is that this small triangle is similar to the medium triangle, is similar to the overall big triangle. And so what we're going to do right now is we're going to look at these statements. We've got 4 proportions, and we're going to be thinking about which single option must always be true. And so what we're going to be doing is we're looking for a proportion that uses one side of a triangle twice, and since that's going to be the geometric mean. And I know that I'm going to be looking at this small triangle to start off with, and I'm going to be comparing it to this overall big triangle. Does the small green triangle share a side with the big red one? It sure does. They both share this blue side right here. They both share AB. So what we're going to want to do is look for an instance in which AB is featured twice in these 4 proportions. And what do I know? I know that if we look at option number 2, it says AD, the short leg over AB over the hypotenuse, equals AB, which is the short leg of the big one, over the hypotenuse. So that, ladies and gentlemen, is the correct answer for number 20, option number 2. Let's take a look at question number 1. It says, the equation of the circle O is this equation right here, and it says the statement that best describes circle O is what? And so it asks us to identify the center and determine if it's tangent to either the x or the y-axis. So the first thing that I'm going to do right now is write the equation of a circle, which we remember is x minus h squared plus y minus k squared equals r squared. All right, so this is the equation of a circle, and we recall that hk equals the center of the circle, right? So what we're going to do right now is we're going to need to figure out what the center of the circle is. So I'm going to rewrite this equation right here. We're going to need to complete the square. So this is going to be fun. All right. We've got x squared plus y squared plus 4x minus 8y equals negative 16. And so I'm going to group the x's and the y's, and I'm going to write it like x squared plus 4x, and I'm going to leave a little bit of a space, plus 4y, because we're going to be completing the square, minus 8y equals negative 16. And so we remember that to figure out what c is, it's going to be b divided by 2 squared, right? And so b in this case is positive 4 and negative 8. And so 4 divided by 2 is 2. Squared is 4. And then if we add it to one side, we've got to add it to the other. If b in this second component of the y's, if b is negative 8 divided by 4, divided by 2 is negative 4. Squared is positive 16. Great. And so now what we need to do is simplify. So I know that on the right side, 16 minus 16 equals 0, and we've got that 4 left over. Great. And on the left side, we're going to have to factor this trinomial, and I know that it's going to be x plus 2, right? And so if we FOIL this, it would give us back this quadratic, plus y what? What times what gives us positive 16, and added together gives us negative 8. It's going to be y minus 4. So what is the center of the circle? Well, when we're looking at x plus 2, we recognize that h has got to equal negative 2, and y minus 4. Y, of course, has got to equal positive 4. So the center of this circle is negative 2, comma 4. And what about the radius? Well, I can see that the equation is set equal to 4, and I recognize that 4 equals r squared. So what is r? It's simply 2. So the radius of this circle is 2. What does that look like? I'm going to want to sketch this out because it's going to help me visualize this and better identify if this is tangent to the x-axis or the y-axis, which is a crucial component to finding the correct answer. So what I'm going to do right now is I'm going to find the circle, and I know that the x value is -2. I know that the y value is +4. So the center of the circle is going to be about right here, right? The radius is 2, and I know that that means it's got to extend to about right here. This circle is going to be, it's going to look approximately like this. That's not amazing, but you guys get the gist. And so what do I know? Well, I know that this, of course, is the y-axis. So what is the correct answer? Well, when we're looking at our options, I can see that we need to find an option where the center is -2, 4, so we can rule out 1 and 2. So it's got to be either 3 or 4. And do we have a center that's both -2, 4 and tangent to the y-axis? Sure enough, the correct answer is option 4. Question number 22. In triangle ABC, segment BD is the perpendicular bisector of ADC. Based upon this information, which statements below can be proven? Great. So the first thing that we're going to do always is sketch this out so we have an idea of what this looks like. And I know that we've got A, B, C, and I saw a moment ago it says BD is the perpendicular bisector. So that's going to look a little something like this. So we've got B, D. Amazing. Well, if it's a perpendicular bisector, then we know that this side is 90 degrees. Likewise, this side is 90 degrees. And if it's bisecting ADC, then this segment is congruent to this segment. All right. Is there any other information that we know? Well, if we can figure out that this triangle is congruent to this triangle, if ADB is congruent to CDB, we can then, I think, prove these 3 other statements, although BD is given because this is the median, right? It cuts from the vertex of one side to the opposite side. So we can say right now that already BD is a median. We can prove that. BD bisects angle ABC. Let's see if we can prove that these are congruent. These 2 triangles are congruent, and I know that they share this side. This is the reflexive property, of course. So we can prove that these 2 triangles are congruent because of SAS. And if that's the case, we remember that congruent parts, corresponding parts of congruent triangles are congruent. And we know that this angle equals this angle. So BD bisects angle ABC. We can prove that right there. And then it says triangle ABC is isosceles. Well, we remember that an isosceles triangle has 2 congruent sides, and we know that this side has got to be congruent to this side, and it is because, again, corresponding parts of congruent triangles are congruent. We can prove that this is an isosceles triangle, so that means that 1, 2, and 3 can be proven. The correct answer is option 4. Question 23. Triangle RJM has an area of 6 and a perimeter of 12. If the triangle is dilated by a scale factor of 3 centered at the origin, what are the area and perimeter of its image, triangle R', J', M'? So we're going to need to determine, of course, the area and the perimeter. We're going to start with the perimeter because that's a little bit easier. We'll return to the area in a moment. And I know that the perimeter of the original triangle, RJM, is 12. And if it's increasing by a scale factor of 3, then we can simply multiply the original perimeter by 3, and the perimeter of this new triangle, R', J', M' is 36. All right, and so that means that we can eliminate options 1, and we can eliminate options 4, and so it's going to be either 2 and 3 because we see the perimeter of 36. But what is this new area? Well, we remember that to find the area, what we're going to need to do is square the scale factor, and I can see that the scale factor is 3, so it's going to be 3 squared times the area of the original triangle, and we can see that the area of the original triangle is 6. So it's going to be 3 squared times 6. 3 squared, of course, is 9, and 9 times 6 is 54. So the area of this new triangle is option 3. Question number 24 says, if sine of 2x plus 7 equals cosine of 4x minus 7, what is the value of x? Well, I know that if we have sine of an angle equals the cosine of an angle, then the sum of these two angles are 90 degrees. It's because they're complementary. So what is that going to look like? If they're complementary, then they add to 90 degrees. So we know that 2x plus 7 plus 4x minus 7 equals 90 degrees. We can simply combine like terms, and so we've got 6x, 7 minus 7 is 0, 6x equals 90. We're going to divide both sides by 6, and when we do, x equals, of course, 15. Is that an option? It is option number 2.